everyone, welcome to XM All Access. I'm Diana Iracheta and I'm excited to be part of this series showcasing some of the coolest minds in STEM. In this series, we'll deep dive into the diverse world of impactful STEM careers and the individuals leading the way in science, technology, engineering, and math. As your guest host for this episode, I am excited to chat with Robotics Engineer Dr. Suzy Young. When you think of robots, perhaps your mind goes to a place in the future where we rely on robots to get from place to place and to help complete our daily tasks. Well, guess what? The future of robots is now. Now, let me tell you a little bit about myself. I am a Latina immigrant and I am a mechanical engineer. I have been working for 5 years as an engineer and I have created organizations that bring the Latina community together who are interested in pursuing careers in STEM and engineering. Now, I hope you're as excited as I am to hear from our speaker, Dr. Suzy Young. Suzy, who has several decades of experience in the field of robotics, is the director of the Research Institute at the University of Alabama in Huntsville. She is considered to be a leader in robotics research and development for government, industry, and academia. Suzy, welcome and thank you for joining us today.
Thank you, Diana. It's really nice to be here. I'm excited to get a chance to talk to your audience today and share some of my experiences.
Let's jump right into our first question. As a robotics scientist with a great deal of experience in the industry, can you give us a brief overview of the field and tell us why robotics is impactful to society?
Well, great. I think maybe we should start off with just saying what is robotics. I will give you a little bit of a shocker here. It's not all R2-D2 because there are many different aspects to robotics, but I'll tell you a little bit about that today. So a robot is anything that can help a person do a job or a task, and this robot can be on air, land, water, underwater, or under the surface of water, and even space. So we have already seen, society has already seen how dependent we are on the help of robots. Whether that be in the area of manufacturing, whether you're making automobiles in a factory, maybe you're operating an automated guided vehicle, an AGV, which works in manufacturing, and it helps to move supplies from station to station in a manufacturing environment. Or it could be as simple as a robot that vacuums the floor for you at your home. My personal introduction to robotics was in research and how these systems can help our soldiers. I worked for the Army alongside the military for almost 30 years, and we were looking at robotics to provide help in dull, dirty, and dangerous environments. Our national security is very reliant on drones right now, which are robots in the air, and we also have robots on the ground for the military. They can be remote sentries, they can be robots that carry weapons, and they can be robots that go underwater or on the surface of the water for patrol.
For many of us, R2-D2 capture our hearts on the big screen, but real-life robotics are revolutionizing industries across the board. Everything from healthcare to manufacturing to exploration and defense, and even helping to keep our homes in order. Building on this, can you share some specific examples of industries or applications where robotics have made a significant impact?
So, yes, I certainly can. And we've already talked a little bit about drones, but I do believe that the most significant impact today is how robot drones can help us both in the commercial world and in the military world. Commercially, we use drones on a daily basis in search and rescue missions. We use drones for law enforcement. We used unmanned ground robots that can safely disengage bombs or perform inspections in nuclear environments. In the military applications, drones are used 24/7 to go out on reconnaissance missions, to do delivery of medical supplies perhaps, or delivery of much needed blood, medical things that in rural areas they're hard to get and they're hard to get fast. Drones can help us with that. And we also have to remember that drones and robots can stay awake and keep us safe and secure without getting tired and falling asleep.
For humans, being able to stay alert around the clock to carry out critical and sometimes life-saving tasks will be like having a superpower. Drones are really incredible. Here's an interesting fact. Considering the applications of robotics across so many different industries, can you give us a few examples of specific jobs that professionals in robotics might have?
I certainly can. I want to back up just a moment here and talk a little bit more about what a robot is. And a robot is a system. And it can be a system of systems. So there are many, many areas that people can find jobs or find things that they're passionate about to work in this area. It could be with the maintenance of the robot itself, learning how to operate the robot, learning how to teach the robot to do tasks, or repair the robot if it's working on an assembly line or carrying supplies in plants. One thing that's important also that might be an area that you might be interested in is helping a robot learn to think. That's called PLC in the manufacturing world, Programmable Logic Controller. And it's an extremely important job because if the robots don't think, then they're not of a lot of use for us right now. So it's the way that we see and how to improve their brain power. That would be a great area to get involved with. We also have welding and painting robots. Those robots don't come ready to do that. It's just like a human. They have to be trained to do that. We have to remember that training these robots, we are teaching them to do things better, faster, more efficient, and without getting tired. More complicated tasks in robotics might require work in an area maybe like computer science, or someone that wants to be skilled in data collection and analyzing that data to resolve problems that we have with robots. Any type of engineer, and we're going to talk a little bit, I think, about different types of engineers, but any type of engineer can work in the field of robotics. There's almost always something there that you can be interested in. The system itself has a controller. It has to be mobile. It has to have a platform to operate from. It has to have payloads. It has to have communications. So there are all kinds of things that mechanical engineers or electrical engineers, computer science engineers could find a home in robots, like I did, for example. So I think one thing that's really interesting right now is the way that robots are learning, and that's with machine learning or artificial intelligence. And that requires the collection of huge amounts of data so that the robot can take this data, digest that, and then come out with answers to hard questions or things that problems we're trying to find answers to in a particular area. So keep an eye out for that. AI, artificial intelligence, is a good thing because it's allowing our systems now to think and take a lot of the burden off of the human operator in situations where it's easier for the machine to do it than for the person to do it.
With robotics technology growing at such a rapid pace, there has been dialogue about whether or not robots might take jobs away from humans. While robots are very efficient at doing certain tasks, they also open up a whole new world of opportunities for us. Someone has to design, build, program, train, and maintain these high-tech systems. Take a look at these job examples in robotics. There are so many different career paths in robotics, and they span a wide range of educational levels. But okay, let's get back to our questions. Robotics is one of those fields that brings to mind futuristic images of technologies on the horizon. What innovations do you see in the future of robotics?
Well, I'll say that looking at the innovations that have come about over the past years has been very exciting for me because I get to see all of these changes that we can integrate into a robotic system that make it better and faster and more helpful to humans. One thing, besides teaching the robot to think, which is what we mentioned about machine learning, it can learn now from its mistakes, it also has capabilities for facial recognition. Facial recognition is especially important to us now because we might need that to identify and track or locate a lost child. It might help us to pick out and identify criminals in a group. Another great innovation is in the locomotion of robots. So we do robots on wheels, we do robots on water, we do robots on tracks, and we have two-legged robots, four-legged robots, and sometimes we have a spider robot that might have 8 legs. So this is just an early prototype that I made long ago to give us a capability of a legged robot, and it can traverse multiple terrains, rocky, treacherous water, whatever. So anyway, these are things that you build one and try it to see how it works. So you might think about that, and if you're interested in robotics, there are kits and there are robotics clubs you can go and get involved and build some of these yourself. Another interesting area is how robots must learn to operate around humans and be aware that their human partners are not in danger. One example of this is the NASA Robonaut. I went to Johnson Space Center in Houston and I met NASA Robonaut. And this is a robot that was designed in conjunction with General Motors and with NASA because NASA was looking for a capability where they could put a robot on the International Space Station and work in a confined area with humans and other astronauts. So Robonaut went to the space station and it showed how it could do repetitive experimentation. When I met Robonaut in Houston, the robot turned and looked at me. It recognized my face. It turned to greet me. It knew where my face was, my hand was, and it reached out with its hand to give me a handshake and put just the right amount of pressure on that handshake. So it was recognizing my safety as a human. And the reason for this for General Motors is because in a manufacturing environment, these robots are surrounded by cages. These huge robots pick up heavy loads, they swing back and forth, and they can be very dangerous to humans that are not paying attention and walk in that area. So this was why General Motors was interested in a Robonaut, or a robot that could work safely with humans and recognize their boundaries.
I would love to meet NASA's Robonaut someday. The idea that we all could be interacting alongside robots sometime in the future is really amazing. Now, you were a member of the initial robotics working group in the US Army Research and Development Labs, where you initiated the first efforts to prototype and test armed ground robots for the US Army. And you did all of this without being enlisted in the military. What was it like working as a civilian for the US government?
I absolutely loved working alongside our military folks, alongside our soldiers, sailors, aviators, Marine Corps, Coast Guard. I got to work across services, which was great. And the reason that I liked working with the military folks is there was a great structure there. There was rigor there that people knew their place. They knew what part they were playing on those teams and what their job was. So that, to me, helped me understand how important it is to work as a team. The other thing I liked about working with the government is they worked towards a common purpose. We all had a common goal. We weren't in it for ourselves, and you could ask almost anyone in either military, civilian, or contractor, ask them who their customer was, and they would always say, it's our soldier. So I'll let you know also that for our country, our military people, our armed forces, are the best trained and best equipped in the world. And that was part of our goal, was to make sure that we maintain that for our soldiers that we worked with every day. What the robotic systems did for the soldiers was to, like I said before, keep them out of nasty environments, dull, dirty, dangerous, and ultimately save lives for our soldiers. That was probably the number one goal, was to put a robot in harm, not a soldier. Working for the government, I will say this, I worked in industry, academia, and the government, but working for the government probably gave me some of the best advantages I could get one of my jobs was to be a technical point of contact for robotics exchanges globally. So my job was to make sure that we had a fair exchange. If we had something that we had discovered, an innovation or a technology, we would share that with other countries. My job was to make sure that they came back and shared the same amount of information with us so that it was a quid pro quo. We were even in our exchanges. So I got to travel a lot of the world. I was also had the benefit of continuing my education while I worked for the government, and they actually paid for three additional degrees. I got an MBA, a master's in electrical engineering, and a PhD from Vanderbilt, and that was all paid for and supported by the government. The other fortunate thing about that was my PhD, my dissertation concentration was in the area of robotics, which I had been loving for many, many years, and now I got an advanced degree, so it was just good all around.
Government-funded college education for civilians working for the military is something that a lot of people might not be aware of. Not only does this make higher education more accessible by removing financial barriers, but it grows the skilled workforce that is ultimately driving the strength and security of this country. Take a look at these other civilian jobs that support the US military. There really are a lot of opportunities for civilians to make a difference. Engineering is such a broad field with so many different options, and it can be overwhelming for a student to decide which path to follow. What advice do you have for students who are unsure on which discipline in engineering is best suited for them?
That is a very important question, and I would say the majority of students that go into engineering are not sure about what field, what area they would go into, what concentration, because there's so many. The best thing about engineering, though, is that you don't have to confine yourself to working in one area, because any field of engineering can go across many, many disciplines. If you're a civil engineer, you might be working in construction, you might be doing road design, you might be doing city planning. If you work in mechanical engineering, you might be making something work or better, or inventing something that's you might get patents on. Environmental engineering is very important right now. All industries usually have to have several environmental engineers to make sure we're complying with green issues across all the fields. Systems engineering is another great field because, like I said, a robot is a system, and so as a system engineer, it would be very good to be in that field so that you could show how that particular machine works as a system. I started working in a facility when I first graduated that made telephones, and I learned about many, many disciplines as a mechanical engineer at that time, because in making those 30,000 telephones a week, I learned about materials, I learned about plastic molding, I learned about metal stamping, I learned about designing tools, and in many other areas I got involved in painting and wiring and assembly. So don't be alarmed when you look at all those fields out there, but do take a minute to look at what each engineering area concentrates on. But I will give you a little bit more advice on that. Before you choose a field, I would recommend that you go talk to a mentor, talk to an academic advisor, talk to a consultant, or maybe someone that's actually in the job themselves. You might not know anybody, but ask around and just say, does anybody know somebody that works in the engineering field? And if you can get in touch with those, I'm sure they'll be more than glad to talk to you. But ask them, what do you do when you go to work every day? What field of engineering are you in, and what do you do when you go to work every day? That will be probably the most beneficial for you in trying to select what field you want to get into. I will say, my first college advisor asked me why I was taking a lot of classes in music, and I said, because I'm on a music scholarship. And he said, what are you going to do with a music degree? and I had no idea. So by the time he explained to me what my limitations were, he asked me what kind of classes I liked in school. I liked math, science, biology, things of that nature. And he said, well, why don't you try an engineering class? And I did. So the first engineering class I took was exactly what I was looking for, but I didn't know at the time until I took a class. So step out and take a class, and it might not be right for you, but it could be, and you probably will make your decision relatively quickly once you start in a course of study at a university.
Doing research to learn what jobs are available in your degree field and what the day-to-day on those jobs actually looks like is so important. That is such great advice. Now, for our final questions, over the course of your career, you must have encountered numerous of new technologies and innovations in your field. Which one was your favorite?
So most of the time our work and our experimentation takes place on a supercomputer. And that means that you're going to be doing in a fraction of the time that you would with a regular computer. You're going to be able to solve problems and develop that data so that it becomes useful to you. Now, the results of this huge amount of data that's coming in is why we now have almost driverless cars. If you think about it, the new cars you buy, you can actually take the driver out of the seat. You might be surprised, but there are driverless 18-wheelers now, and they are legal in 7 states. You might want to check that out. You'll see that they look different because guess what? You don't need a cab on an 18-wheeler anymore because you have no person inside. So just keep those kind of things in mind. You can look these up online. Unmanned air taxis are also available now in many cities, so you might be taking a robotic air taxi one day. And then finally, think about drone swarms. And if you'll notice how birds fly, those are called murmurations, is when you see a flock of birds that fly through the air. We have drones that now do that, can do it on a regular basis with high accuracy as far as navigation, maintaining the distance, and knowing the direction that they're flying. They can be used for many things. One thing you might have seen is in entertainment. If you've seen a drone light show, you've seen murmurations in action.
Wow! Driverless 18-wheelers, unmanned air taxis, and drone swarms. I can see why it would be so hard to pick just one. There are so many exciting and innovative things happening in the world of robotics. Suzy, thank you so much for joining us today.
Well, thank you, Diana, for having me here. I've loved being able to talk about things that I'm passionate about. I hope you students find something that you're passionate about as well. And if you do, you'll enjoy a great career, and there will always be changes in everyone's career because technology does not stand still. So just be ready for that and enjoy the ride.
I really enjoy learning about the diverse applications of robotics and the many ways this cutting-edge industry is impacting our lives. Robots are no longer a futuristic concept. They're used every day to perform tasks that improve our lives, like manufacturing, healthcare, home maintenance, space exploration, and even helping keep our soldiers safe. I hope you enjoyed learning about this field as much as I did. Thank you for tuning in today. Make sure you subscribe to the YouTube channel in the description below and follow us on social media to get updates about new episodes. You won't want to miss any of them. Plus, you'll get access to fun weekly content for students and teachers, such as STEM facts for students, classroom tips for teachers, and so much more. And don't forget to check out the full library of episodes available on demand right here. Each one has an NGSS and CASEL-aligned lesson plan for teachers to use on the classroom. With your parents' permission, tell us how you were inspired today by tagging us at USA Science Fest, #XSTEM, and me at Latina_Engineer on Instagram to keep up with the Latina community. I had a blast being your host today. But don't sign off just yet. You want to stick around through the end of this video for a fun trivia game that you can do so in the classroom or at home. Have fun and good luck!